Okay, this one's a Pythagorean theorem. If you don't know this one, you're gonna be suffering when you get old. So, number one, so here's a 90 degrees. So you always have to use the two segments that comes from 90 degrees. So here's a square plus, and then from the 90 degree, you get this one. It's 12 square. Must be equal to the hypotenuse, and hypotenuse is always across from the 90 degree. That would be 15. So 15 square. So if you square things out, 12 squares 144, 15 squares 225, subtract 144, you're gonna get 81. And then you square root on both sides. Well, let me rewrite one more step. On this one, you don't need to write down plus or minus because it cannot be a negative number when you are measuring length. So just positive. So positive square root of 81 is 9. Sometimes you get a whole number like 9. Sometimes you get a square root of a number. And then if it's a square root of a number, you need to simplify it in the next problem. Okay. Like number 3 and 5, 3 through 6, you need to leave your answers in simplest radical form. So let's just do number 5. So this time your A smallest is, it has to touch the 90 degrees. So two sides that comes out of 90 degrees. So smallest is 6 square plus the medium x right here. Like I know you cannot see it, x square. And these two can be switched. It could be x squared plus 6 squared. It does not matter because you're adding. But one thing that must be by itself is the hypotenuse, which is 12 square. So longest side must be by itself. The other two sides doesn't matter. So 36, 144 again. And then subtracting 36, you're going to get 108. Okay, and then if you get rid of squares, you by square root it. Now this time, square root of 108, you do need to simplify. You cannot leave it as square root of 108. And please do not give me decimal numbers. What is a decimal number? That would be like 10.39230485. I don't want decimal numbers because there's in the later sections, you need to see the pattern with the square root. So you must simplify. So I'm gonna start with 4. 4 times what gives you 108? You could do 108 divided by 4, but 4 times 27. Now 27 has another one in it. 27 is made up of the 9. I'm looking for the perfect score numbers like 4, 9, 16, 25, 49, 64, 81, those numbers. So when 4 comes out, it becomes 2. Okay, so 4 is gone. It doesn't stay as 4. And when 9 comes out, what's the square root of 9? Square root of 9 is 3. So 3 comes out. So outside is 3 and 2, and between them is a multiplication sign. Why do we times it? Because it's, it came from 4 times 9. So 3 times 2 gives you 6. Square root of 3 is the answer. So when you're simplifying, always try 4, 9. Usually those work. Sometimes 25. Okay. So one of those has to work. 4, 9, 25, or maybe 49. Okay, number 7. You already have square roots. Yeah, but it's the same policy. You start with the 90 degree. You multiply Pythagorean theorem, a square plus b square. Okay, so x square plus square root of 7 square, which is not bad. I mean, you could still do it. Yeah, square root of 7 squares, just 7. Oh, don't do square root of 49, which happens to be 7. That's kind of, 7 squares 49, and then you square root it, you get back to 7. That's kind of not a good way to do it. Just cancel it out, and you get 7. Okay, now the next one is where people make mistake. 2 square root of 2 is the c, so c, and then you square it, and that's where you make the mistake. What mistake? Most people see that as 2 times square root of 2 square, which happens to be 4. But it's not 4 because 2 squared is 4. Now what we're doing is 2 square root of 2 whole thing square. So what you forgot is the parentheses. Even if you're using this in a scientific calculator or graphing calculator, you need that parentheses. Okay, otherwise people will just cancel out the square with the square root, and that will leave you with 2 times 2, and that's wrong. So when you put this parentheses, this becomes 2 squared, and this becomes square root of 2 squared. They both get the square. That's where, that's the correct way to do it. So just like before, with the square root of 7, the square root cancels out and you get 7. And then here, square cancels out the square root, but it doesn't cancel out anything here. So it's 2 squared, which is 4, and 4 times 2, which is 8. A lot of people would put 4 there and then get it wrong. So now if you subtract 7, you get 1, and square root on both sides, you get x equals 1. If you get square root of a negative number, you know something's wrong. So that's kind of important. So 2 square root of 2, when you square it, they both get the square. The first 2 gets the 2 square, and then square root of 2 gets the square. Okay. Now, backside, special right triangles, find the missing side of each triangle. So it's the same thing. We're using Pythagorean theorem, but you notice that you notice a pattern. You notice something about these. Okay. So for example, number 9, you still have a 90-degree here. So this is A, this is B. So it turns out to be same number. Yeah, that's a special case. Used to be different numbers up to now, but now it's the same number. 4 squared plus 4 squared equals hypotenuse x squared. So if you work this out, this is 4 times 4, 16, not 8. And 4 times 4, 16. If you notice, all the questions ends up having same 2 numbers. Okay, so 16 plus 16 is 32, which happens to be twice of 16. Oops, did I put equals? Oh my god. Okay, so this should be equals. So back to the point. Yes, you could add 16 plus 16, but it's better to leave it as 2 times 16. Why? Because you're going to take a square root of it. And then the 16 which came from square will cancel out the square root. So you want to leave it as, it's always going to be twice of these numbers. So 32 is what we got, but 32 happens to be 2 times 16. So square root on both sides. Equal sign. So now when you do square root of 2, it does not come out. You just square root of 2. But what is the square root of 16? Square root of 16 is 4. Oh yeah, that 4. Right, so x is equal to 4 square root of 2. You see the pattern? Do you see what's happening? Well, let's just do one more. So there's a 90-degree here. So it's 2 squared plus 2 squared equals hypotenuse, the longest side, x squared. Same number again, 2. So 2 squared is 4, 2 squared is 4. Again, yes, it's 8, I know. But hold on, I just told you it's better to leave it as 2 times 4. I know it's 8, but 8 is 2 times 4. Why not just add 2, 4 plus 4? Well, you see the pattern that it's always going to be, these numbers will always be you'll be able to square root it. So just leave it and then just go, well, it's 8, but 8 is 2 times 4. Okay, so when now you square root it, so square root of 2 stays and the 4 comes out, and 4 becomes square root of 4 becomes whole number 2. And that's the answer. So hopefully you notice something. So if you get some big numbers, like number 16 is 64, yeah, you don't want to square root something like that, but that's why we want to notice the pattern right away. Okay, so 4 and 4 gives you 4 square root of 2, and 2 and 2 gives you 2 square root of 2. And 7, well, let's just do it. So 7 squared plus 7 squared equals x squared. That's Pythagorean, A, B, C. That's 49 plus 49. I keep changing to plus sign. So I don't know what 49 plus 49 is. I do, it's 98, but I don't need to know 98. Just 49 plus 49 is twice of 49. You have two 49s. Okay, so now when you square root it, well, 49 comes out, and then square root 2 stays. 49 comes out and becomes what? 7. 7 square root of 2. Okay, well, what if you have weird numbers like, number 15 square root of 55? It doesn't matter. Square root of 55, that's what we have. Square root of 55, another one, square, equals x squared. Well, turns out that this cancels out, you get 55, and this cancels out, you get 55. Yeah, it's 110, but you know what? Keep it as twice of 55. And when you square root it, it's back to square root of 55 and square root of 2. Right? There should be one square root symbol, but I turned it twice. So what we have is we still have square root of 55, but we times it by square root of 2. So this is square root of 55 times square root of 2, which turns out to be square root of, oh yeah, we do need to multiply this time, or add 110. That's the answer. So with the 7, you couldn't multiply 7 times square root of 2, you're done. But with the square root of 55, you can multiply square root of 55 times square root of 2. They're both square roots. If you multiply, you get square root of 110. Okay? So, yep, just if you're not sure, just keep using Pythagorean theorem and please discover the pattern, because that's the shortcut. Okay, have fun.